So good afternoon, students.
Good afternoon, sir.
Yeah. So yes, good afternoon. Now listen, everyone write down how to start this one. Soluble, physical, problem, supporter, all right. Pay attention. Some new insights about stem cells. Already we know everything. I don't want to go those basics again and again. So my thing was, so yesterday I said types of stem cells. Next week we got 20 types of stem cells. So we have embryonic stem cells, adult stem cells, and induced pluripotent stem cells. Right? Induced pluripotent stem cells. Then I discussed something about niches. Niches. What is the meaning of niche? The microenvironment. The microenvironment is called as niche. Do you remember what do I mean by microenvironment? For example, this is a bone marrow, right? This is a bone marrow. Now the bone was cracked here, assume. Okay. Whatever cells we are keeping here, whatever stem cells, pluripotent stem cells we are keeping near this bone marrow, okay? Near this cracked region. Simply, this cracked region will release some chemicals. Okay? These chemicals are called as cytokines. Please write it down. Cytokines. Cytokines are also called as cell-messaging molecules. Cell-messaging molecules. Cell messengers. Okay? Any two cells will communicate each other by cytokines. If there is any cell 1, cell 2, they will communicate each other by releasing some type of cytokines, some type of chemicals. Okay, I will give one best example of this one. T3 cells and T4 cells communicate via some hormones. Here the messaging molecule became a hormone. Okay. In case here any other cells will communicate by cytokines. Now, whenever this cell releasing a chemical, okay, whenever a cell releasing a chemical, that chemical will act specifically to a target cell. I will give one example. T3 hormone always targets the thyroid gland. So T3 hormone has a specific target, that is a thyroid gland. So similarly, these cytokines are also specific in nature. How these hormones are working, how these cytokines are working, that we need to understand. How a cell understood the cytokine signal. How it understood means, now this cell has a specific receptor to accept this particular chemical. These cell receptors, RECV, receptors. Each and every cell has various types of receptors. Receptors means they will receive signals. They will accept something inside and they will allow something to go outside from the cell. Cell receptors. Okay. These receptors are called as markers. Markers. These receptors are called as markers. Okay. If you remember our induced pluripotent story, first we have an adult cell. Then Mr. Shinya Animato, what he did, he took adult cell, he kept it then on a petri dish, and he given 4 molecules, right? Transcription factors, c-MYC, SOX2, then a nano-G, and one more thing. So there are 4 chemicals that he induced. He suspended cell in the chemicals. What happened by these chemicals? These chemicals entered via those 4 receptors in the cell. The receptors accepted these chemicals, and these chemicals will reactivate all the chromosomes, leading to conversion of an adult stem cell to a pluripotent stem cell. Now it became pluripotent. Pluripotent means it can able to make make almost all types of cells in the body, right? Pluripotent has the tendency to make mesodermal, ectodermal and endodermal. So this is called induced pluripotent stem cell. So in this, what I introduced to you was stem cells has a markers and these markers has certain names. So I will give some basic markers if you already know. There is a type of T cell called helper T cell. In case of HIV viral infection, HIV virus will utilize a receptor on helper T cell called CD4, cluster differentiation receptor 4. HIV will utilize the CD4 to gain access inside the helper T cell. That is why helper T cells are also called as CD4 cells. Then there is one more type of cell that is called cytotoxic T cell. This cytotoxic T cell has a surface marker or receptor called CD8. And I forgot the exact receptor name. In case of red blood cell, okay, even red blood cell has many receptors by the way. These receptors are also called as antigens. If red blood cell has a antigen, A receptor, that is called A group. If it has a B group, it is AB, or if you don't have any receptor, that will be a O group, right? Similarly, red blood cell has one important receptor that is called CXCR. CXCR, what does this CXCR do? Actually, CXCR present in you are late. Anyway, malaria parasite. Malaria parasite requires this receptor to enter inside the red blood cell, to infect the red blood cell. Malaria parasite requires this receptor. It will utilize this receptor as it will unlock the door and it will go inside the red blood cell. Now it will start anemia. It will feed on the red blood cell. Now, what the evolution did? Something very interesting. In the Africa, people are dying with malaria. So what they did was, if there is a gene mutation, that mutation leads to removal of CXCR. Once CXCR removed, it comes with a punishment. The punishment is the mitochondrial cell became sickle cell. But now, this sickle cell will protect them against malaria. But what is the punishment? Now they are anemic. So this is a beneficial mutation in that particular location. Rather than dying with malaria, living with anemia is better. Okay. So you need to just focus on the receptors. Receptors plays a vital role. These receptors called as markers. Each and every cell in our body, we have around 200 different types of cells. Each and even though any two cells, this is a cuboidal cell and this is another cuboidal cell. Cuboidal cell, this is a G cell from stomach and this is a secretory cell from the salivary gland. How to differentiate this cuboidal cell from this cuboidal cell? Obviously, these both cells have various types of receptors. They don't specific receptor. So each and every cell has its own specific receptors. These receptors are also called as markers. Got my point? So markers plays a vital role. By detecting the marker, we can able to understand what type of cell it is, what type of stem cell marker or lineage it took. So in a nutshell, even stem cells will, we can say stem cells like this. They are a genomarker cell. Now it will specifically developing some markers, indicates that it is becoming a particular type of cell. Got it? So just you need to change the cellular expression, the marker expression. An empty CD, after you are loaded with some data, it became a loaded CD, right? Similarly, an empty stem cell, once it differentiated, now it will make a specific markers leading to that particular cell. It became an adult. It became a differentiated cell. You got my point, Tableau. So we have a stem cell, it don't have any marker. Now it wants to become a red blood cell. What marker it should develop? CXCR. So if it develops CXCR receptor, definitely it is differentiated into a red blood cell. So the idea is simple. What type of marker expression the cell going to express? Expressing means the type of marker it's going to show on the surface of the cell. Accordingly, the cell will become. Okay, so just keep these markers in your mind. I hope that now you got clarity, right? What are those? In case of your question, the markers are pluripotent markers, induced pluripotent stem cell markers. Okay, yeah. Anyway, next one. Definitely there will be markers for totipotent cell, marker for pluripotent, marker for unipotent and adult cell. So everything will have their own markers. That's clear for us. Next one, I'm focusing on niches actually. Today I was supposed to finish this topic, which is stem cell niches. Yes, come fast. So the niches means, please the microenvironment, right? Whatever stem cell we are keeping, this microenvironment will mold the nearby stem cells to convert to those cells that are required cells nearby. I don't know how I need to convey this message to you. Now, it is very complicated thing. See, not only bone marrow cells, not only it's becoming a bone marrow cells, it also need to convert to bone cells, it also need to convert to blood vessel cells. Multiple types of stem cells required there. Multiple lineages they need to take. It's a very complicated thing. Not a one or two thing. Multiple things will decide. So one stem cell will take lineage of becoming blood vessels to refill the blood vessels connecting to the bone marrow, and some cells must become a bone, the bony part, and some stem cells must become they should take the hematopoietic pathways. Hematopoietic pathway means RBC, WBC, platelet pathway. So it's a very complicated tasks going on. As of today's technology, we can only make a single lineage of stem cells, but not all. We can either make only this bone marrow stem cell, or we can only make the bone stem cell, or we can make only cell that can make a blood vessel. But all together making an entire organ is not possible. Very complicated. Damn complicated. Even after ChatGPT, all this, where we went to moon. Even after this technology, still, life is one of the most complicated things. So keep that aside. We'll see later. So what factors contributing? What is the niche? Not only chemicals. There are some more things that are decided. So let us see. The niche was broadly categorized into two areas. When I say niche, microenvironment. The niche has two types. Write down. First one, cellular niche, non-cellular niche. Cellular niche, we already understood. Definitely there will be some cells. Obviously, first thing will be stem cells. Stem cells will be converted to nearby another cell. That is okay. Next, other cellular niche. Very interesting and most challenging. That is immune cells. Are nearby immune cells going to accept these newly formed stem cells? Are nearby helper T cells, cytotoxic T cells, neutrophils, basophils, are they going to accept this new stem cell as a cell? Yes, if it is our own stem cells. Imagine yesterday, Mr. What is your good name, Mr.? Not Anupam, behind him. He also asked one question. What is your name? Currently asked a question. Let me reframe this question and I will come here. The immune system as my question was here. Is our immune system going to accept the new stem cells? Anupam said yes. I am saying no. I will let you know why the second case. Imagine we have a patient one with blood cancer. he has a bone marrow cancer, leukemia. This patient has a leukemia. Why he developed leukemia? Maybe genetically he got an issue. His bone marrow, rather than making a good blood cells, is making a cancer white blood cells, cancerous cells. Okay, it can be lymphoid leukemia or it can be myeloid leukemia, acute and chronic, lymphoid and myeloid leukemias. If that is the case, definitely his genes got affected. How to treat this patient? Now there is only one option. The option was, first of all, I know we will take a healthy patient, we will take his bone marrow and we are going to transplant this bone marrow here. We are going to transplant. Before that, we need to check his immune system going to accept these cells or not. For that we are doing typing, matching, immune matching. That is called as HLA typing. Now listen, this is called HLA typing, just like a fingerprint. Every immune system has our own fingerprints. Every one of us are unique at immune level. If I cannot simply take his heart and transplant it. My body is not going to accept the organ. It will treat it as its foreign. Now once we go for matching, getting 100% match is impossible. Only one possible scenario, that is when you have a identical twins. Where even twins have two different, identical and non-identical. Only identical twins will have matching, or your nearby cousin, your brother, sister, mother, father. Even mother also 50-50, because half of her genes came to us, not her full genes. Okay, or nearby cousin. But getting 100% matching is impossible. So what doctors used to take was, they will go with weightage. First of all, availability of the donors and the severity of the recipient. After transplanting, is my recipient age? What is his age? If he is old person, doing this is not when egg also available, we will take him as first priority. Because the donors are very less, scarcity of donors. So there are multiple parameters to decide. And another one is, up to 80 to 90% we can get a match. So after 90% match, we are going to transplant this bone marrow to him. Now keep in mind what happens. That 10% didn't match, right? Immune system will slowly attack the transplanted bone marrow, because it is not completely accepting it. Now there is a balance between immune attacking and regeneration of the cells to compensate, to refill the gap. But at one point, sometimes immune system will overtake, and at that time we will get a complication called graft versus host disease, transplantation failure. Okay, so very challenging. See, definitely what I am transplanting his stem cells into his. First I need to destroy his stem cells first, because those stem cells has cancer. First I need to empty his bone marrow. Am I correct? First my cancer patient bone marrow must be emptied. Got it? How I will empty my bone marrow? I will give chemo. I will give literally toxins such a way that they will destroy your cells. I am under controlled conditions, I am killing a patient immunologically. I remove all his bone marrow. Now he can die with a simple flu. A simple cold virus can kill my patient because he is a zero immune person now. He needs to be kept in a highly hygiene room. A simple dust inhaling can kill him. Very, very challenging situation. In this situation, I am going to transplant it, okay, and I need to ensure that his immune system accepts the graft. And it will take, that is called acceptance. That acceptance will take 3 to 6 months. Okay, so up to 3 months we need to take care of him. We need to constantly monitor his CBC values. Is his CBC values rising or not? Once CBC values rising indicates successful transplantation. So it's not as easy as we think. Very challenging. Okay. We know stem cells are right candidates, but there is this problem, immune niche. That is what I am saying here. In the niche, in the cellular component, is my immune system going to accept me? Accept the stem cells. That is called immune niche. We need to consider that. Okay. One niche was immune system. Another niche was stem cells themselves. And third niche, the third niche was supporting cells. Yeah. See here. Supporting cells. Supporting cells means other one here, supporting cells. Apart from bone marrow, definitely we need some glial cells, some healing cells. So supporting cells also will act as a niche microenvironment. All of them must be accepting. This is just cells now. Okay. Let us assume they accepted. They accepted the new stem cells. Now, another criteria we are missing. That is, let us assume the non-cellular things, bone was very rough and stem cells are unable to attach them. Again, that became a failure. What my point? The bone marrow, the bone was rough and it's not smooth, or it is over smooth. We need some rough surface so that cells can bind to the walls of the bone. So I given a very layman term, rough wall. The actual term will be matrix, extracellular matrix. In reality, all cells are stitched together by a fibers. Those fibers called collagen fibers. To these collagen fibers, just like these buttons, this cloth is like a collagen fiber, and these buttons are cells. So cells are stitched to the matrix, collagen fibers. Is my matrix has an appropriate matrix? I cannot make an umbrella with a sari material, right? With a cloth, I cannot make an umbrella. It must have some plastic way, something that will block water. So those are called non-cellular components. The non-cellular niche microenvironment includes extracellular matrix. The type of extracellular matrix we are using that include, the purpose of extracellular matrix is it will provide structural scaffolding. Scaffolding means support. Okay. To be precise, when we are constructing this building, they will give this iron rod side. So that is called scaffolding actually. So scaffolding, and it contains integrates something that will bind the cells tightly. Okay. Next one, soluble factors. Non-cellular, we got soluble. Cytokines, we got growth factors. Is my patient has right growth factor hormones that can stimulate the near cells upon getting differentiated. So I need to check the soluble factors such as cytokines and growth factors. You already know what are cytokines, right? Cell signaling molecules, messaging molecules. Next one is physical factors. The physical factors include the stiffness, the elasticity, the oxygen tension. What is this? Lesion. Oxygen capacity of that microenvironment, simply. Whether that particular microenvironment getting adequate oxygen supply or not. If it's not getting, again that's a challenge. Hypoxia. Lack of oxygen, cells will go senescence, means that will die. So I also ensure that whether it's getting right oxygen, elasticity and other physical parameters. So 1 and 2 completed. Cellular niche we need to consider, non-cellular niche we need to consider, and third one, they say signaling pathways. Signaling pathways. So what are the signaling pathways? So I don't know how to tell you signaling pathways is. There is one pathway called or programmed cell death pathway. So it is